Dear participants of the conference, let me share my screen with you. Sorry, it doesn't work somehow. Dear participants of the 5th International Workshop on Computer Modeling and Intelligent Systems, Zaporizhia, Ukraine, May the 12th, 2022. Here's the report presentation on the topic of entropy modeling of optimal intelligence development in regards with the air transport operation. My name is Andriy Goncharenko. I work for two institutions. One of them is Xi'an Jiaotong University, which is the transport university in China, the city of Xi'an. The second, my occupation is Air Transportation Management Department at National Aviation University, Ukraine, Kyiv. So this poster is dedicated to the problem statement. As you see, first, entropy modeling. So entropy modeling implies traditional view entropy of the Shannon's type entropy, formula number 1, but instead of probabilities, here we have preferences functions. They are also normalized for 1. So the entropy is the traditional view. And according to the variational calculus optimization, we may obtain formulas number 2. These are the so-called canonical distribution of preferences. Although I emphasize one more time, preferences are not probabilities, although they are very, very similar. And in this context, entropy or degree of uncertainty is for the preferences functions, but not for probabilities. One more thing I'd like to emphasize, that according to the literature review, entropy studies are very popular for nowadays, and sometimes they are applied for safety issues. For example, the topic of my presentation is about aviation system operation, and the top priority in aviation, it's the risk management, so flight safety, to decrease the negative consequences of possible failures of aircraft as a whole, of the systems, of the engines, of the elements of the systems. So it all combines with the economical issues and uncertainty studies. And it's realized in the theory of subjective preferences or active systems. The theory is developed by Professor Kasyanov, National Aviation University, Kyiv, Ukraine. For the last 3 decades, we worked on applications. And in fact, the traditional view entropy, which is formula number 1, it doesn't show the direction of certainty or uncertainty. For example, if we consider the simplest case, so theoretical background for this study presented here, this is 2 alternative case when alternative number 1 has the preference of 0.351, and accordingly to the normalizing condition for 1. So the second alternative will have 1 minus 0.351, which yields 0.649, formula number 3, formulas number 3. And in this case, the entropy, the measure of uncertainty of the situation and preferences of the effectiveness functions for operation would be at some level. But this value will not change at all if the situation is vice versa. Look at formulas 4. For example, first alternative have the same as the previous case, second alternative, 0.649. And that's why for the second case, alternative number 2 will have 0.351 preference function value. Thus, the entropy of the view formula number 1 shows no difference with respect to the direction of certainty or uncertainty. And that means we cannot distinguish between wrong or right, correct or bad inclination of our system or intelligent conflict situation. Talking of intelligence, I'd like to say one more thing, that in order to decide, is it good or not so good artificial intelligent system, we must have some imagination of how the natural intellect works. And this is also referred to subjective analysis, or the theory of subjective preferences of active systems. When active element, a person, an individual, makes a decision with respect to the uncertainty of situation and with respect to the preferences distributed upon the effectiveness functions according to the alternatives or options. Now, let me tell you something about the possibilities, how to solve, for example, this situation when we do not see which is good and which is wrong in our decision. There's a proposed, the so-called hybrid pseudo-entropy relative function, formula number 5, which combines the traditional view entropy, h of pi, and maximum value, and then relative value of that. Also, we take into consideration the sign of the preferences function or index of intelligent conflict management alternatives preferences, and the domination of good over the wrong or bad preferences. You see a formula 7. It depicts the positive and negative alternatives respectively, and the number of alternatives m plus l equals n, the total number of options or alternatives. Applicably to some engineering problems, for example, it can be in aviation, and the problem is maximal duration horizontal flight or maximal distance horizontal flight, and the speed of the flight will be different, formula number 9, and the aircraft and the pilot has or autopilot has to choose between these two contradicting or conflicting options. Next, it can be some effectiveness functions described with a system of differential equations, for example, like 11. These are the equations of the system of the ordinary differential equation of the first order, but nevertheless, it can be any mathematical object which models the effectiveness situation, but then it will be transformed in the system of preferences, canonical distribution of which is the formulas number 2. This is canonical distribution of preferences, and according to that, uncertainty situation would be measured with the entropy, but traditional entropy, you see figure number 11, it doesn't show us any kind of direction of this uncertainty. It shows that periodically system distinguishes something and gets certain to some distribution, but it doesn't show to which direction. But for the 3 alternative case, figure number 12, it exactly shows that at the time point of about 2 and 6 and 10 and about 19, the system gets certain to the first alternative, which is considered to be positive, and it's in accordance with the formula number 5, because in this case we got the plus sign, positive value of the domination or prevalence of the positive preference over the negative ones. So for discussion section, we have all this discussed, and you see these time points about 2, about 10, and about 9 time units. And in figure 12, it was shown exactly in the explicit view, because traditional entropy doesn't show that. Also, one more advantage of the proposed hybrid function, that it shows us the relative value. For example, some magnitude of traditional entropy doesn't say about how close this uncertainty to the maximum degree, but this relative function shows the relative value, because positive +1 and negative -1 certainty and 0 value for the hybrid entropy function. 0 value is complete uncertainty. This is why we might come to the conclusion that the entropy theory of conflicts in general sense can be successfully implemented to the solutions of the intelligent conflict management in the terms of the conflict genesis, development, transitions, and exodus. So all stages of the conflict development of evolution can be considered through the prism of this subjective analysis theory, and it's helpful with the proposed hybrid function to evaluate the degree of certainty or uncertainty in the relative value, relative scale, and positive and negative side. So also the optimal generalized input intelligent resource value found with the use of the resources generalized perceptions functions entropy conditional extremization, and that ensures maximum value of the intelligence growth output. Further endeavors is proposed to be made in the field of values estimations. All these coefficients have to be somehow estimated, and variations, modifications to the functional also has to be made. So that's all for now. Thank you very much.